So we're going to do one more by the ratio test. So here we go with this series here. Looks crazy. So let's just look at a to the n plus 1. So this is going to be 2 to the 3 n plus 1 to the n plus 1 factorial cubed all over 3 n plus 1 factorial. So if I kind of rewrite this a little bit, I can say this, that this is equal to 2 to the 3n plus 3 times n plus 1 times n factorial, all that cubed, all over 3 to the n plus 1 factorial. So now we're going to just put this all together now. So if we take rho equaling the limit as n goes to infinity, and on the top it's going to be all that an plus 1 business there, so that's going to be 2 to the 3 n plus 3, and then I'm going to have the n plus 1 n factorial, and I can just do this. I can just do cubed on each of those, and then just get rid of this here altogether. This will kind of save us a step. And that's all going to be over 3 to the n plus 1 factorial. And if I think about this, the bottom is really just a sub n. So I'm just going to do that times here and then that flip. So this is really just going to be 3 to the n factorial cubed all over 2 to the 3n n factorial cubed. So I simplified the rest of this. Now I'm just going to do some canceling out here. So this n factorial and n factorial, this n factorial cubed and n factorial cubed here, this 2 to the 3n is going to cancel that 2 to the 3n. This 3 cancels with this 3. This n plus 1 cancels with one of those and makes that a 2. So then let's just see what we're left with. So this is going to be the limit as n goes to infinity, and it looks like we have a 2 to the 3rd left from this piece here, which that's going to give me a 8. And then it looks like the rest of what we have is just n plus 1 squared. And if we think of this limit here, this limit is actually infinity. This would imply that rho is bigger than 1, which implies the series of n equals 1 to infinity of, I'm just going to write a sub n, diverges by the ratio test. I can't just write RT because we have a root test we're going to talk about next.